All right, 9, as promised, here are your test corrections. So let's take a look at this first one. So we have a trinomial here, and we are subtracting another trinomial. So the first thing we want to do is get rid of the bracket. So it's like this is being multiplied by 1. So this becomes 4x squared plus 4x subtract 7. And then we're subtracting a trinomial in these brackets, and so if you remember, when we subtract an expression, all of the terms in the expression change sign. So this is going to become positive 2x squared, this is going to become positive x, and then subtract 3. So now we can add our like terms. So we have 4x squared plus 2x squared is 6x squared. We have 4x plus x is positive 5x. And we have negative 7, subtract 3 is negative 10. All right, so looking at B. So here we have a trinomial being divided by a monomial. So whenever we divide by a polynomial by a monomial, we have to divide every single term in the polynomial by that monomial. So we're going to do 12x to the 4th divided by 3x squared. Well, 12 divided by 3 is 4. And x to the 4th divided by x squared, we just use our exponent laws. So in this case, we know that when we divide like terms, we have to subtract the exponent. So we would have x to the 4 subtract 2, which is 2. Then we're going to look at the next one. So we have negative 3x cubed divided by 3x squared. Well, negative 3 divided by 3 is negative 1. And then x cubed divided by x squared. Again, we're dividing, so we subtract the exponent. So 3 minus 2 is 1. And lastly, we have positive 6x squared divided by 3x squared. So positive 6 divided by 3 is positive 2. And then x squared divided by x squared is 1. So in essence, it would be 2 times 1. And I'm just going to leave the 1 here for now for those of you that still don't see what happens. So if we take a look at this then, we have 4x squared minus x, because we don't have to write the 1, and then plus, and then 2 times 1 is 2. Okay? So if we go on to the next one, here we have a monomial divided by a monomial. So all you're doing is you're dividing the like terms. So we can divide the 10 by the 12, we can divide the x to the 5th by x squared, we can divide y squared by y squared, and we can divide z to the 10th by z. So if we divide 10 by 12, it's going to be a repeating decimal, so we're just going to reduce the fraction to 5 over 6. Then if we divide x to the 5th by x squared, well, we're just going to subtract the exponent, so 5 minus 2 is 3. When we divide y squared by y squared, we just get 1, so I'm just going to write the 1 for now. And then when we divide z to the 10 by z, again we subtract the exponent, so 10 minus, and remember there's a 1 here, so 10 minus 1 is 9. So we are left with 5 over 6, and then we have times x cubed times z to the exponent 9. So if we look at our last one here, this is very similar to the one above. Here we had a trinomial divided by a monomial. Here we have a trinomial multiplied by a monomial. So again, we're going to multiply every single term in the trinomial by the monomial 2x squared. So I'm going to multiply 2x squared by 3x squared. Well, I'm going to take the 2 times 3, which is 6, and x squared times x squared. Well, I add the exponent, so it becomes x to the 4th. And then I'm going to have 2x squared times negative 1x. So 2 times negative 1 is negative 2, and x squared times x is x cubed. And then I have 2x squared times negative 4. Well, 2 times negative 4 is negative 8. And then there's nothing to multiply the x squared by, so it stays exactly the same. So I have multiplied every one of the terms. All right, so moving on to solving. So when we solve an equation, right, we want to get x all by itself. So we're undoing all of our operations. So in this case, we were subtracting 8, so that means to get rid of this, we want to add 8. So we're going to add 8, and we're going to add 8. So now I'm left with negative 4x is equal to 84. So now I want to undo the operation of multiplication. So I'm going to divide both sides by negative 4, And when I do so, I end up with x equals negative 21. So now let's look at one that is a binomial equal to a binomial. Well, here we want to get our x's on one side and our numbers on the other. So I'm going to start with getting an x on only one side of this expression. So I'm going to get rid of the x's over here. So I'm going to subtract 3x and I'm going to subtract 3x. So now I'm left with negative 7 is equal to 3x plus 11. So now I don't want any numbers over here because I want to be left with just an x on this side. So I have to get rid of the positive 11. So to do that, I'm going to subtract 11. And what I do to one side, I do to the other. So I'm left with 3x equals negative 18. And now I need to still get x all by itself. And right now it's being multiplied by 3. So I need to divide it by 3. What I do to one side, I do to the other. So I'm left with negative 6 is equal to x. All right, so now let's look at the last question on this page. It says to perform a check, and that's in bold. So I didn't want you to solve anything. I just wanted you to tell me whether if x was equal to 3, that this side would equal this side. So you just simply have to substitute the 3 into both sides. So let's do that. So we're going to do 2, and then we have 3 plus 5 minus 2. So replace x with 3. So we have 3 minus 4. And that's going to equal, and so on this side we have 3 times 3 plus 7. So if we work the left side here, I have 2 and 3 plus 5 is 8, minus 2 and 3 minus 4 is negative 1. And then I'm just going to keep working the left side for a minute. So I have 2 times 8 is 16, and negative 2 subtract 1. When I multiply those together, I get plus 2. And so then I have 16 plus 2 is 18. So now let's work down the right side and see if this side is also equal to 18. So I have 3 times 3 is 9, and then plus 7, and 9 plus 7 equals 16, and so now I have 18 equals 16. Well, that's not true. So since that isn't true, then therefore x equals 3 is not a solution. And you didn't have to show all of these steps. You could simply have shown the substitution step and then done the work in your calculator, as long as you had shown me that those two sides would not be equal when x was equal to 3. All right, so now we're on to application, and our first application says write and solve an equation to find the length of the sides of the following rectangle if the perimeter is 24 centimeters. So first we'll write an expression for perimeter. Well, we know that the perimeter of a rectangle is 2 of the lengths plus 2 of the width. So we're going to write perimeter is equal to, I'm just going to write 2L plus 2W. And in this case, we don't know which one is L and which one is W, but we can still substitute. So we're going to do 2. We're going to make L, in this case, 3x minus 4. And we're going to make the width the other side then, so 2x plus 1. So we know that in this case, the perimeter is this expression. So I can expand and simplify this expression. So 2 times 3x is 6x, and 2 times negative 4 is negative 8. And then I've got 2 times 2x is positive 4x, and positive 2 times positive 1 is positive 2. So now I know that I can simplify this. So 6x plus 4x is 10x, and negative 8 plus 2 is negative 6. So now I have an expression for my perimeter, which is 10x minus 6. So this is the expression for my perimeter, and I know that my perimeter is 24 centimeters. So I'm going to replace P with 24, and that's going to equal 10x minus 6, and now I can solve for x. So I want to get rid of the 6 on this side, or the negative 6, sorry, so I'm going to add 6. So then I end up with 30 is equal to 10x. And then I want to get rid of the 10 here, so the only way to do that is to divide by 10. So now I know that x is equal to 3. Well, that's great, x is equal to 3, but that is neither a length or a width, right? So in order to figure out what the lengths of the sides are, I've got to plug that 3 back into those two equations. So if I said that the length was 3x minus 4, and now I know that x is 3, then I know in this case that my length has to be 5 centimeters. And I know that my width is equal to 2x plus 1, and so in this case x is 3. So then I know that my width has to be 7 centimeters. So therefore the length is 5 centimeters and the width is 7 centimeters. Don't forget your units. All right, so now we want to simplify a more complex expression using the power laws, because if we look here, every single thing is being multiplied across, so we have everything here. This is to a power, and then it's being multiplied by this monomial, and then all of this is being multiplied by this monomial, which is to a power. So there's no addition and subtraction in this question, so I'm going to use my exponent laws. So if you remember, whenever we simplify a fraction question, we always simplify the numerator first, then we simplify the denominator, and not until we have a simplified numerator and a simplified denominator do we do the division. So let's simplify the numerator. So here I'm going to look at the first expression. So all of this is cubed. So that means that -2 is cubed. Then I have x cubed cubed. Well, when I have a power to a power, I multiply them. So that's 3 times 3, which is 9. And then I have y squared cubed. So again, a power to a power, so I multiply them. So that's y to the 6th. Then I have this other bracket over here. Well, that's just saying that I have -1 times x times y to the 4th. So then my denominator, so let's try and simplify that. So I have this negative here, it's like there's a -1, so I have -1 squared. Then I have x squared squared, well that's just 2 times 2, which is 4. I have y squared squared, well that's just 2 times 2, which is 4. And then I have z, and there's a 1 here, so it's just 1 times 2, which is 2. So now I keep looking, and in this case, I still can simplify my numerator further, so I'm going to simplify it further. So I have -2 cubed, which is -8, and -8 times -1 is +8. Then I have x to the 9th times x. Well, remember there's a little 1 here, so 9 plus 1 is 10, so I have x to the 10. And then I have y to the 6th times y to the 4th. Well, 6 plus 4, so I have y to the 10. Then I have -1 squared. Well, -1 squared is 1. And then I have x to the 4th, y to the 4th, and z squared. So now I'm going to divide only my like terms. So if I take a look here, I can divide these numbers, and I can divide these x's, and I can divide these y's, but I can't divide the z's. So that means the z doesn't do anything. It just stays where it is because there's nothing to do with it. So 8 divided by 1 is just 8. X to the 10 divided by x to the 4th is x to the 6th, and y to the 10 divided by y to the 4th is y to the 6th. Remember, we subtract the exponents, and then we're done. So moving on to solve the equation. So this is a more complex solving of equations, so we have to simplify this side and simplify this side before we can start adding and subtracting. So here, to clear I want to clear the bracket, so it's like there's an imaginary 1 here. So to clear the bracket, I just multiply everything by 1, so it's x minus 6. Then I'm going to multiply everything in this bracket by -3. So -3 times 2x is -6x, and -3 times 1 is -3. And then I'm going to do the same thing over here. So -2 times x is -2x, and -2 times -3 is +6. So now I can simplify this side further, so I'm going to do that. So x minus 6x is -5x, and -6 minus 3 is -9, and then I can't simplify this side any further, so it's just -2x plus 6. So now I want to get rid of the x's on one side, so I normally get rid of the smaller x, so I do negative 5x. To get rid of it, I add the opposite, so 5x. Make sure I do it on this side. So now I have negative 9 equals 3x plus 6. Well, now I have x's all by themselves. I don't want this 6 anymore. I want to get rid of it, so I do the opposite. So I subtract 6. Make sure I do it on both sides. So now I have negative 15 is equal to 3x. So now I don't want the 3 anymore, so I'm going to divide by 3. I'm going to divide by 3. So now I have x equals negative 5. Okay, moving on. So our last two questions. So here we're supposed to rearrange the formula s equals 2 pi r times r plus h. So what you probably want to, in this case, we may just want to expand and simplify first. So if we do that, we have 2 times pi times r times r. So we're going to have 2 times pi. We can only, r times r becomes r squared. And then we have 2 times pi times r times h, so we just write 2 times pi times r times h. So here we want to isolate h, which means we want to get h on one side. So there's no h's here, so we can subtract this from both sides. So I'm going to subtract 2 pi r squared, and I'm going to subtract 2 pi r squared. So when I do that, I get s minus 2 pi r squared is equal to 2 pi r h. So now I know that this is 2 times pi times r times h, so I don't want the 2 pi r, so I can just divide by it. So I'm going to divide this side by 2 pi r, and I'm going to divide this side by 2 pi r. So what I'm left with then is s minus 2 pi r squared divided by 2 pi r is equal to h, and I'm done. So the next one, number 5, the perimeter of the triangle below is 20x minus 1, and we want to determine a simplified expression for this side. So I know that the perimeter of this, triangle is going to equal the sum of all three sides. So a plus, and then remember, whenever you have an expression and you're adding it, you put it in brackets, so 8x minus 3, plus, and then I have an expression, so it goes in brackets, so 6x minus 2. So if I simplify that a little bit, well, now I can multiply this bracket by 1, so it's just going to be 8x plus 3. And I can multiply this bracket by 1, so it's just going to be 6x minus 2. And the reason we put it in brackets, because if there was a negative here, then all of these signs are going to have to change, so you couldn't just write subtract and then this expression. So it's really important that you remember to put it in brackets. So now I have p equals a. I can simplify this, so 8x plus 6x is 14x, and then 3 minus 2 is 1. So now we know here from above that the perimeter is 20x minus 1. So I'm going to replace p with 20x minus 1, and that's going to equal a plus 14x plus 1. Well, I want to determine an expression for a, so a is the only thing that I want left here, so everything else has to disappear. So that means I'm going to subtract 14x from this side, which means I have to subtract 14x from this side. So I'm going to have 6x minus 1 equals a plus 1. And so now to get rid of this 1, I'm going to subtract 1, and I'm going to subtract 1 from this side. So I have 6x minus 2 equals a. So therefore 6x minus 2 is a simplified expression for the unknown side. And this time it didn't give us any units, so you can either just write units or you can just write 6x minus 2. All All right, solving equations. So this is our favorite, fractions. So we want to actually get rid of our fractions, and a lot of you have been putting two different methodologies together. So maybe watch this one a little bit carefully so that you can see how to completely work through one method. So what I like to do is I like to say, okay, well, what can 2, 9, what's the smallest number that 2, 9, and 16 can go into? And so that is going to be 18. So 2 can divide into 18, 9 can divide into 18, and 6 can divide into 18. So that means I want to multiply this whole expression by 18. Okay? So that means I'm multiplying every single thing inside that expression, because like I have a monomial on the outside where 18 gets multiplied by this, by this, by this, and by this. So I'm going to have 18 times x over 2 plus 18 times 1 equals 18 times 2x minus 2 over 9 minus 18 times x minus 2 over 6. So every single thing has been multiplied by 18. Well, now I can easily divide 18 by 2, and when I do, I get 9x. And I can easily multiply 18 by 1, and I get 18. And then over here I have 18 times an expression divided by 9, so that means I can actually divide the 18 by the 9, and I have 2 then times that expression. And then I have 18 times an expression divided by 6, so I can actually divide the 18 by the 6, and when I do that I get 3. So I'm going to have 3 times x minus 2. Well, now I have an expression like on the other page. I just have to expand and simplify it. So over here I already have a binomial simplified, so I don't have to do anything to it. And here I'm going to multiply the 2, so 2 times 2x is 4x, and 2 times negative 2 is negative 4. Now, notice how here I have a negative 3. Remember, whenever you have a negative outside of a bracketed expression, all of these signs are going to change. So I have negative 3 times x, which is negative 3x, and negative 3 times negative 2, which is positive 6. So I have 9x plus 18 equals, well, now I simplify this side, so 4x minus 3x is x, and negative 4 plus 6 is positive 2. So now I want to get x's on one side, so again I always try to get rid of the side that has a smaller amount of x's, so x minus x and 9x minus x. So I have 8x plus 18 equals 2. So now I need to get rid of the 18, so I'm going to subtract 18. So I have 8x is equal to 2 minus 18, which is negative 16. And now I want to get rid of the 8, so I do the opposite operation. I divide by 8, so I have x equals negative 2. All right, we're almost there. We're on the thinking question. So this thinking question, be really careful. You can't multiply, you can't bring the 2 in, because that power law only holds when it's a multiplication, and we have an addition here. So it's not the same thing. If you have xy squared, well, that equals x squared y squared. But if you have x plus y squared, well, that equals x plus y times x plus y. Very different, okay? So in this case, we want to undo all of the things. So we want to still get x by itself, so we have to undo everything. And if you remember, we always undo in the opposite order that we apply. So instead of doing BEDMAS, we do BEDMAS backwards, or SAMDEP, okay? So if you look, the bracket is the last thing that happens. So we have a bracket here, so that's the last thing we're going to touch. So it doesn't matter what's inside the bracket. If there's a bracket, you don't do anything that's inside the bracket. So that means the first thing we're going to do is we're going to get rid of this negative 5, or this subtract 5, because that's what it tells us. So to get rid of the subtract 5, we're going to add 5 to both sides. So now we have 2 times x plus 3 squared is equal to 32. Well, we still have this bracket here, so we know we have to touch that dead last. So it's being multiplied by 2. and then it's to an exponent. Well, multiplication comes before exponent, so we're going to divide both sides by 2 to get rid of that 2. So 2 divided by 2 is 1, so we're left with x plus 3 squared is equal to 16. Well, still, the bracket itself we don't touch, but we can get rid of the exponent, and we know that anytime we have something squared, to undo it, we're going to take the square root of both sides, and that gets rid of our squaring. So we have x plus 3 is equal to, and the square root of 16 is 4. Okay, so now I can subtract 3 from both sides, and I actually end up with x equals 1. All right, next one. Determine a simplified expression to represent the area of the shaded region. So this is a shaded region. So we have this big rectangle, and if we get rid of the area of the small rectangle, we'll be left with the area of the shaded region. So we know that the area of the shaded region is going to be the area of the big rectangle minus the area of the small rectangle. So area is always length times width. In this case, we have 3x and 6x plus 4. When you multiply a monomial by a binomial, you always put the monomial first. So we're going to write 3x times 6x plus 4. From that, we want to subtract the area of the small rectangle. So here again, we have a monomial and a binomial. So when you multiply a monomial and a binomial, you always put the monomial first. So 2x times 3x plus 3. So that's an unsimplified expression, and so now we want to simplify it. So when we simplify it, we're just going to multiply. So 3x times 6x, you multiply 3 by 6 and you get 18. And x by x, well, it's like there's little ones here. So 1 plus 1 is 2, so it becomes x squared. Then we do 3x by 4. Well, 3 times 4 is 12, and there's nothing to multiply the x by, so it just stays. Then we are going to multiply negative 2x by 3x. Well, negative 2 times 3 is negative 6. And remember, it's like there's little ones here, so x by x, you add the exponent, so it's x squared. And then we do negative 2x times 3. Well, negative 2 times 3 is negative 6. There's nothing to multiply the x by, so it's just x. So now we add and subtract like terms. So we have 18x squared minus 6x squared is 12x squared, and 12x minus 6x is plus 6x. And so now we have an expression, and we know that that expression is in meters squared, so we're just going to write that. All right, so here we have a word problem. So Fred, Wilma, and Dino play Splatoon with each other online. Dino has 5 less wins than Wilma, and Wilma has 4 times more wins than Fred. So what I would do is I would start with Fred, okay, in my let statement. So it says write an expression to represent their total number of wins and define the variables. So we're going to let x represent Fred's wins. So now I know that Wilma has 4 times more wins than Fred. So that means that it's 4 times, so it's going to be 4x. So let 4x then represent Wilma's wins. And then we know that Dino has 5 less wins than Wilma. Well, we know that Wilma is 4x, so if Dino has 5 less than that, then it's got to be 4x minus 5 that's going to represent Dino's wins. So now we have to write an expression for their total number of wins. So we know that the total number of wins is going to equal x plus 4x plus 4x minus 5. So that's going to equal x plus 4x is 9x minus 5. So we know the total number of wins is going to equal 9x minus 5. And now we are asked if they have 184 wins in total, how many wins does each one have? So if our total is equal to 9x minus 5, then 184 is equal to 9x minus 5, because we replace total with 184. So now we're going to add 5 on both sides. So I have 189 is equal to 9x. So now I want to get rid of this 9, so I'm going to do the opposite. I'm going to divide by 9, and so I know that 21 is equal to x. Well, x is Fred's wins, and I know that Wilma's wins are 4x, and I know that x is 21, so that's going to be 4 times 21, which is 84. And I know that Dino, his wins were 4x minus 5. So that's going to be 4 times 21, subtract 5, which is 84, subtract 5, which is 79. And then this is Fred. So therefore, Fred wins 21 times. Wilma wins 84 times, and Dino wins 79 times. All right, we're at the last page. So now you need to write a scenario that can be modeled by the following equation. All right, so you can look back at that previous question and come up with one. I am going to come up with one. So let's say there are 3 siblings, Lise, Denny, and Carolyn. So I'm going to say that Lise is 3 years older than Carolyn, and Denny is twice as old as Carolyn. So then if their combined age is 30, how old are they all? So you just want to come up with a word statement that represents each of these expressions. Okay, so it's not simplified, so, and they're not in brackets, so each of these are 3 different things. So if X is obviously Carolyn, Denny is twice as old as Carolyn, and Lise is 3 years older than Carolyn. And then you're done. Communication. Circle the error and briefly explain what the students did wrong. So let's take a look here. Well, we have -2 times x is -2x, and then here we have this negative out front, and we have 2 negatives which make a positive, and they didn't do that. Okay, so here we know that -2 times -8 is positive 16. Now if we look over here, this goes back to the question that we were doing earlier. Anytime we do a question that deals with getting rid of fractions, we want to make sure that we multiply every single term by that common multiple. So here, the common multiple was 12. This can divide into 12, and this can divide into 12. So what they didn't do, though, was they didn't multiply the 5 by 12. So it should have been 12 times 2x minus 1 over 4 plus 12 times 5 equals 12 times x minus 1 over 3. There was a second mistake in this, and that was here, where they added -3 plus 5 and got 2, and when they subtracted 2 from both sides, they got -1, and that would not have worked. But this was the one that I was hoping that you were all going to catch. Okay, so this is the first one, so let's just put a 1 here. This is the second mistake. So for the second mistake, and I'll just do it up here, we would have had, so let me just put them both, we would have had 6x plus 2 equals 4x minus 4, and so then we would have subtracted 4x, and we would have subtracted 4x, so then we would have had 2x plus 2 equals -4, and then we would have had to subtract 2 and subtract 2, and we would have ended up with 2x is equal to -6. So if you found either of those mistakes, I gave you a mark. And the very last question, Sam says that 3x plus 7 is a binomial, and Julie says it's a polynomial. Who is correct? And explain your answer. Well, a polynomial is the addition or subtraction of terms, right? It could be one, two, three, four, on to infinity terms. So in this case, right, a binomial is a polynomial with 2 terms only. So in this case, they are both correct. So binomial is just a special name for a polynomial with 2 terms. All right, hope that helps.